So at the beginning of the school year, teacher asks every student in the class to fill out a survey that asks for their age, sex, number of years they've lived at their current address, favorite subject, and whether they plan to go to college after high school. Which of the following best describes the types of variables? So we have two types. You've got the quantitative and you have the categorical. So quantitative are variables that you can answer with a number. It's something that you can measure. It's something that you can count. Okay, categorical are going to be variables that are answered with words. So, for example, if I said, what grade are you? You could say, I'm a senior, I'm a junior, freshman, sophomore. Those would be the categories. But in this particular case with that, you could also say 11th grade, 12th grade, 10th grade, 9th grade, because though in that case, the numbers aren't being used to count. Okay. All right. So when we look at this, their age is something that you measure with a word, with a number. Sex would be with a word, so that would be categorical. Number of years you've lived at your current address, that would be a quantitative. Okay, your favorite school subject, you'd answer that with a word, so that's categorical. Whether you plan to go to college or not, you'd answer that with a yes or no, so that would be a category. So we have 1, 2 categorical, and we have 1, 2, 3. I'm sorry, we have 2 quantitative, and we have 3 categorical. So our answer is D. Okay, what's the overall shape of the distribution? So when our distribution's tail is more to the left, we say that's the direction that it's skewed in. So this is skewed left. Okay, if it looked like something like that, that would be what skewed right looks like, because the tail is to the right. Here, the tail is to the left. Okay, the mean of this distribution. So this distribution is skewed to the right. And so, excuse me, it is skewed to the left. Okay, and what that translates to, the median is going to be where the peak is. And whichever direction it's skewed to, so in this case, it's skewed left, the mean gets pulled that direction. So the mean would be to the left of the median here. It would be a smaller value. If something was skewed to the right, then the mean would get pulled to the right, as you can see over here, and it would be a larger value. So in this case, the mean is going to be less than the median because it's getting pulled towards the left. All right, based on the shape of the distribution. So we've got a distribution here that is skewed to the left. Okay, which numerical measures would best describe it? Well, if you look down here, you've got measures that deal with the center, which are your median and your mean. And then you've got measurements that talk about the variability, how spread it is. That's the standard deviation and the IQR. If you've got data that has outliers or is skewed one way or the other, you want to use the measurements that aren't affected as much by the skewness. So if you have outliers or the distribution is skewed, we want to use the median and the IQR to measure the center and the spread. So on this example here, since it is skewed, we want to use the median and the standard deviation to measure the spread, because they're not going to be as affected by the skewness. Which of the following choices gives two measures that are both resistant to outliers? So the ones that are both resistant to outliers are the ones that you'd want to use when you have outliers. Okay, so if there are outliers in the distribution, we want to use the median and the IQR because those are resistant. That's this right here. So my answer is C. The figure displays a computer output for the data on the amount spent by 50 grocery shoppers. All right, and the question is, what's the correct pair of lower and upper cutoffs to identify outliers? So on your review sheet, under Chapter 1, you'll see this little section where it says how to find outliers. So the lower outlier, we take the first quartile, which is right here, and we subtract 1.5 times the IQR. Okay, the IQR is the difference of these two. So however far these are apart, that is your IQR. All right, so let's calculate that first. Okay. Okay, so our IQR 45. Is 2613. So to get the lower outlier, it has to be less than Q1 minus 1.5 times the IQR. And the higher or upper outlier is going to be bigger than Q3 plus 1.5 times the IQR. Okay, so our lower would be anything below negative $19, which doesn't make any sense because you're not going to spend negative money. And then on this one, anything above 84.60. So our answer would be E. Okay, suppose a biologist studying the mechanical limitations of growth among different species of tulips monitors a national preserve. He collects data on the heights of 10 different types of tulips in the reserve and rounds each height to the nearest centimeter. Okay, so here's our heights. And then it says compute the first quartile. So what you have to do first is put these in order from least to greatest. Okay, so I put them in order from least to greatest. And now if we're asked to find the median, that's the middle term. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to get the position of the median, okay, you take n, the number that you got, you add 1, and you divide by 2. So I've got 10 numbers. So that's 11 and a half, 11 over 2, which is 5.5. So what this tells me is that my median, the median is halfway between the 5th and the 6th number. So 1, 2, 3, 4, 5, 6. So my median is the average of these two, which is just going to be 25. Okay, now to get the lower quartile, we're going to repeat this, but we're going to do the median of the lower half, the lower 50%. So the number that is right in the middle got 5 terms. So 24 is right in the middle. That would be quartile 1. Okay, if we needed quartile 3, that would be halfway on the upper. So this has got 5 terms. The third term would be the upper quartile. So our lower quartile is 24. Okay, the next one is just find, it's the same data, find the upper quartile, Q3. So we did that already up here. It would be the middle of the upper half of the data, which is 29. Okay, so our IQR, it's Q1 the value of Q3, take away the value of Q1. Q3 is 29, Q1 is 24, so my IQR is 5. Okay, compute the lower cutoff. So here's our formula for lower cutoff. Quartile 1, 24, minus 1.5 times the IQR, which in this case was the difference of the IQR is this distance, 29, take away 24, 5. Okay, which is option 1. Okay, so to get the higher one, we already did it earlier, but it would be, our high outlier would be Q3 which is 29 plus 1.5 times the IQR, which we already know is 5. And then I calculate that out. So this would now be 36.5. Okay, realtors collect data in order to serve their clients more effectively. In a recent week, data on the age of all homes sold in a particular area were collected and displayed in this histogram. The standard deviation of the distribution of the house age is about 16. What does that mean? The interpretation of standard deviation we learned in chapter 1. And it's right here. So we're going to take that and we're going to fill it in the context of the problem that we're given. All right, so the standard deviation in house age was 16 years. So if I'm going to interpret that, I'm going to fill this in. Okay, interpreting the standard deviation, in this case, we're talking about age of a house. Okay, that's the context. Okay, typically varies by, so we're dealing with standard deviation was what, 16? Yeah, varies by 16 years. Okay, from the mean of, now they don't tell us what the mean is in this problem. Okay, so we can't fill that in. So we would be looking for the age of the house, typically varies by about 16 years from the mean age. So our answer is 1, or A. Here's another hint. When you're looking at standard deviation, you're always kind of looking for this word typically. Okay, not all of them, but typically the majority of the ages are within 16 years above the mean or 16 years below. Okay, Nobles Amusement Park in Ellisburg, Pennsylvania has earned acclaim for being an affordable family-friendly entertainment venue. Nobles does not charge for general admission or parking, but it does charge customers for each ride they take. Dot plot shows the distribution of ride costs. What percent of the rides cost $1.50 or less? All right, so to figure that out, you're going to first get how many rides they have. So that's going to be the total number of dots. So what I'm going to do to get their percentage is I want to find the total number of rides. And then I want to find the number of rides that are $1.50 or less. So our total number of rides, the total number of dots here is 22. And then out of those 22, these 12 right here are $1.50 or less. So then to get my percentage, I'm going to do 12 divided by 22, and that gives me 54.5%. Okay, here are the travel times in minutes of 20 randomly chosen workers in New York State, along with a dot plot. Find and interpret the median. That would be the middle score. Okay, so to do that from a dot plot, we want to find the position of the median, which means we take the number of dots, 20, add 1, divided by 2, that's 21 divided by 2, which is 10.5. So that means the median is going to be located halfway between the 10th and 11th dot. So I start counting down here at the bottom. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's going to be halfway between this dot, that's the 10th dot, and this dot, which is the 11th. All right, so the 10th dot, it has a value of 20, and this 11th dot has a value of 25. So we're going to add those two up and then divide that by 2. Which is 22.5. Okay, so by definition, it's the middle, so 50% of the travel times are greater and 50% are less than the median right there. All right, so we've got the data of 9 different McDonald's fish and chicken sandwiches, and this tells us how many fat and grams each sandwich has. So to find the interquartile range and interpret it, you have to put the values in order from least to greatest. All right, and then what we're going to do is divide it into 4 parts. That's where we get quartiles. So you got 9 numbers up here. So the position of the median is going to be located, I got 9 numbers, so a 9 add 1 divided by 2. So that's going to be the 5th value. So my median, 1, 2, 3, 4, 5 is 21. Now, to get the IQR, I have to find the interquartile range. I got to find the median of the lower half. So the lower half has got 4 numbers in it. So the median would be located halfway between 17 and 19, which is going to be 18. So that's Q1. And now the upper half, the median is going to be halfway between the second and the third number. So that's going to be halfway between these two, which is 27. And that's Q3. So to get the IQR, we subtract those two. So this is 9 fat grams. the range of the middle half of the data, which is the IQR, is 9 grams of fat. Okay, what is the value of Q3 on this box and whisker plot? So the different parts of a box or whisker plot is the minimum, which is the lower whisker. Q1 is the left side of the box. The line in the middle of the box, or in between the ends of the box, is the median. The right edge is Q3, and then this value is equal to the max. So in our case, Q3 would have a value of 15. Okay, the middle 50%. So what the different quartiles do is they divide this area, this distribution up into 4 equal parts, or 25%. So between the minimum and the first quartile, that's going to be 25% of the data. Then between the quartile and the median, which is the line inside my box, that's going to be 25% of the data. From the mean up to the upper quartile, Q3, that's going to be another 25% of the numbers. And then finally from Q3 to the max, that's going to be my final 25%. So it divides the data into 4 equal parts. The question is, what's the middle 50? So the middle 50 is the same as the length of the box. Okay, so the middle 50% would go from 8 up to 15. So the lower limit, or the lower quartile, is Q1. It's got to be less than Q1 minus 1.5 times the IQR. Okay, which measure of center is more appropriate, the mean or the median? All right, so if the data is skewed, then right here, if you got outliers or skewed, you want to use the median before you use the mean. And we got a slight skew right here to the right, so we're going to use the median to measure the center as opposed to the mean. So this one's asking, which one would you use since it's skewed? We want to use the median. It's not as sensitive to the large values over here on the right because of the skewness. Okay, which of the following represents a distribution that is skewed to the left? So we're looking for the tail is on the left. So this first one, both tails are kind of the same length. The second one, your tail is longer to the right, so this one would be skewed right. And then the one that we're looking for, it's got its tail left. So this would be our choice for representing a distribution that is skewed left. Okay, if a mean of a data set is less than the median, what conclusion can you make about the shape? Okay, so if the mean was less, that means if we had a graph here, okay, and I had a median, and the mean was smaller, that means the mean would be to the left of it. Then that means that the tail of my data is going to go to the left. So we're going to have data that is skewed left. Okay, that would be this example right here. Okay, all of the sets below have the same mean. Set 1's got a standard deviation of 3.1, 2, 4.9, 1 or 3, 1.7, and 4, 3.2. Which set probably has the most points closest to the mean? So what standard deviation means is it tells you typically how far the data is from the mean. Okay, so this one right here tells us that typically the data is within 3.1 points of the mean. So for set 1, that means typically the data is within 3.1 points of the mean. All right, so if number 2 here, this would be 4.9 of the mean. So this has got the most spread right now. It's got the largest standard deviation. So this has got the most spread. So the smaller standard deviation is going to have the least spread, or the most around closest to the mean. So that's going to be 1.7. It's got the smallest standard deviation. Therefore, it has the smallest spread of data. So set 3. The box plot below represents the number of absences per student over a semester by a group of seniors at a local high school. Which of the following must be true? So we're going to use what we learned about box plots and how they distribute the data into 4 parts, each being 25% of the data. All right, the IQR is 10 days. So the IQR is measured from quartile 1 to quartile 2. So this distance right here, 5 take away 1 is 4. So this is false. Okay, the mean is 2 days. We can't tell the mean from a box and whisker plot. We can tell the median, but not the mean. About 50% of the students miss from 1 to 5 days. So that's talking about 1 to 5 days is this box. And that this box is made up of 25% here of the data and 25% there. So 50% of the data is in that box. And that box goes from 1 to 5. About 50% of the students miss from 5 to 10 days. That would be false because this is going to be 25%. So my true value in this one is B. All right, so when it says to order the dots from least to greatest standard deviation, least is telling you that's the least amount of spread. So the one that is bunched up the most, which I think would probably be choice A, and then probably D. So that would be the least. So I know it's going to start with A. Okay, and then I would say D is next. So if this was the smallest, this would be the next one up. Okay, and now between B and C, all right, if you look at the spread, B is more spread out than C. So I'd say C is the third, and B would be the fourth. So A, D, C, B, choice A. Okay, what is the median score? So the median is the middle score. So I'm going to put this data, it's already in order because of the stem and leaf plot. So I want to count, see how many scores I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, there's 19 terms or 19 numbers. So the median, the position of the median is 19 plus 1 divided by 2. It's the 10th value. So here I counted from the smallest value up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 7 is my median. I should have 9 numbers in front of it and 9 numbers past it. So that represents a score of 87.